Hello DroidCon Uganda. Welcome to my talk, 10 Reasons to Try Kotlin Multiplatform. My name is Pamela Hill and I'm a developer advocate at JetBrains. So during my talk, if you have any questions, please go to slido.com and enter this code. You can quickly snap it on your phone and I will be answering the questions depending on whether there's time, either on live in this stream, or I'll be answering them on Twitter later. My Twitter handle is Pamela A. Hill. So I'm going to give you like 1 or 2 more seconds to quickly snap that, but I'll also be displaying it a little bit later. So let's start by just contextualizing what Kotlin Multiplatform is. It is a technology by JetBrains that allows development teams to share common code between different platforms. Now, perhaps you're wondering what kind of platforms are supported. Well, it's server, mobile, which includes Android and iOS, desktop, which includes macOS, Linux, and Windows, and web, which includes JS and WASM. So as of the 1st of November, Kotlin Multiplatform is now stable and we're very excited and we hope that you are too. It was in beta for a long time and alpha before then, and so now the technology is stable. So my first reason for saying that you should try Kotlin Multiplatform is that it's already being used by big companies. And this is just a sample of all the companies that are using Kotlin Multiplatform in production, in their major applications, and they're featured on our case studies page. And I see perhaps a few very interesting names there. So let's zoom in on just a few of them. So firstly, we have Meetup, where they use Kotlin Multiplatform for their organizers app to sort of like unify the business logic. And they found that using Kotlin Multiplatform, they could simultaneously release new features on Android and iOS, that their team productivity increased, and that they strengthened collaboration between their Android and iOS teams. Next is Netflix, where they used Netflix used Kotlin Multiplatform for their Prodigal app for film and series creation, and they found that it improved the speed of their feature delivery. Next is Philips, a Dutch electronics company, and they use Kotlin Multiplatform to build a cloud SDK to simplify their app developers' interaction with their cloud infrastructure. And they found that the implementation of features was faster, that the maintenance was easier, and that there was more interaction and knowledge sharing between their teams. You can find the rest of the case studies, the different things that might have interested you on this case studies page. My next reason for saying that you should try Kotlin Multiplatform is the extensive list of supported platforms. So we have server, Android, iOS, desktop, web, which includes JS and WASM. Now, perhaps you haven't heard of WASM before. And WASM is WebAssembly. It is a binary instruction format for portable virtual machines. And it is smaller and faster than JavaScript. You don't actually write your code in WASM, but rather in a language like Kotlin, and then you compile it to WASM. And it's already supported by most modern browsers and also Node.js. So I'd like to sort of illustrate this reason by telling you the story of Quizlet, which is a learning platform that helps you learn and also practice your learning. They have about 5 million users per month, and on Android, they have 10 million active installs. On iOS, they're top 10 in the education in the App Store. So they did try other technologies like JavaScript, React Native, and also C++, Rust, and Go, which is quite interesting. And they found that they really were struggling with these technologies, that it wasn't the right fit for them. So finally, they settled on Kotlin Multiplatform, and they're using it on their Android, iOS, and web applications. So this was the results that they achieved, is they had type-safe APIs when marshalling objects. When they were marshalling objects between types, they had type-safe and null-safe APIs. The performance on Android and iOS improved. For example, there was a 25 times faster grading of your assignment than the JavaScript version that they had achieved with Kotlin multi-platform. And the Android app size decreased, and there was a better developer experience because, of course, they were using Kotlin, which is a modern language with great tooling support, and there were different team members keen to try writing shared code. So initially, it was just the Android and iOS developers writing shared code, and then later it was backend engineers, and then even the web developers were impressed with what Kotlin could do. Another scenario is sharing code between your clients and servers. Think about like data models. So before, when I worked at a company before, we were using something called protobufs or protocol buffers, which is a language neutral, platform neutral language. And what you do is you define a proto file that has your data models inside of it, and then you compile your protobuf files into a specific language like Go for your backends or Kotlin for Android and Swift for iOS. So you can use it with any language that has a particular plugin for it, like Go, but you have to learn yet another format. And you also have to generate each time there is a change to your protofiles, the data classes again for all the platforms. So what you can do instead is share your data models with Kotlin multi-platform, and you can use a familiar language with great tooling, and you can write once and use it everywhere. And you just have to consider, does it support all the languages that it needs to? Remember, on server side, only JVM. So my next reason for saying that you should try is a supportive community. So there is a Slack workspace, and I hope that if you haven't heard of it before, that you'll go and enroll into the Kotlin Lang Slack workspace of 56,000 members, where you can ask questions on various topics, but there's also multi-platform and composed iOS channels. And you can ask JetBrainers, Googlers, and other knowledgeable experts some questions about whatever you're having trouble with, or you can just ask questions in general as well, and they will answer them for you. So there's a lot of open source library developers there as well, answering questions about their libraries. This is a graph showing the multi-platform libraries by year for Kotlin multi-platform, and you can see that initially it was quite slow when Kotlin multi-platform just came out in 2017, and in 2021, there was definite uptick in the amount of libraries. It was starting to grow very nicely. And we're hoping and we're also seeing that there will be more and more each year. So I'd like to sort of give a shout out and also encourage you to follow these companies and individuals for more news and more content about Kotlin multi-platform. So firstly, Google has taken a lot of their Android X libraries and made them multi-platform, so they're compatible with Kotlin multi-platform. And for example, the paging library, data store, and so on. TouchLab is a company from the US that has really created a lot of tutorials and open source tools like Sky that really help the community in using Kotlin multi-platform better and more. John O'Reilly creates really great samples. So if you're wondering how to best implement it according to a specific architecture, John O'Reilly's samples is just definitely the way to go. Philip Blackner creates beautiful tutorials on Kotlin multi-platform, and my colleagues Sebastian Eigner and Garth Gilmore are very knowledgeable about Compose multi-platform. Lena Stepanova created a very beautiful Came Pizza application, and she wrote a very extensive tutorial that doesn't just sort of have this very simple, just read-only interaction with the web service, but it also writes back to this web service, and it shares data with the backend, and it goes all the way to AWS. And Tadeusz Chris is very well known in the community for his knowledge on Kotlin native. Another reason is that it avoids duplication. So I'd like to tell you the story of the Wonder app by Baidu. Now, Baidu is the largest Chinese language search engine in the world, and the Wonder app was created for younger users for educational and entertainment content. Now, the problem that they had was that there was inconsistencies in the app experience for them and the high cost of verifying business logic. So they had an Android app and they had an iOS app, and they were starting to have these problems. There was also high upgrade costs and maintenance costs. And finally, they said the complex and inconsistent business logic of the iOS and Android apps led to increasing maintenance costs for the app. So they decided to go in 2 steps. They started with a little experiment of unifying the data layer, and they started sharing the data model, the RESTful API requests, JSON data parsing, and the caching logic. And then they decided, okay, yes, this experiment has succeeded. And then they decided to adopt the MVI pattern, model view intent, which is sort of like a competitor to MVVM, in order to be able to unify interface logic. So here they started sharing code like low-level data, processing logic, and UI processing logic. And this was the results. They had a consistent experience amongst Android and iOS. They had a reduced cost of maintenance and testing, and they improved their productivity. Yet another reason is that you can use it in new or existing projects. You don't have to start from scratch every time. So a good example of that we just had a look at was the example of the Wonder app by Baidu, of an existing project that they were using Kotlin Multiplatform with, and a example of new projects where they started the project from scratch is the story of 9gag, the funny meme and video page. So they tried other technologies like React Native, Flutter, and so on. And finally, they settled on Kotlin Multiplatform because they wanted to align the behavior on both platforms. So they started on Android, and then they decided to consume as a dependency their Kotlin Multiplatform project on iOS. You can also start sharing your code. Start sharing your code gradually. You don't have to start big bang. So you can start really small with just a constant, or migrating a small common utility, or writing and migrating some business logic. And this is a sort of like a result from a survey where we asked for Kotlin Multiplatform, not Compose Multiplatform, Kotlin Multiplatform, what parts of your code people were able to share between platforms. And you can see that data validation and serialization was quite high. Networking and internal utilities, analytics and logging was sort of on the same level. And algorithms, data storage, and state management was a little bit less. Next, you can choose what to share and what to write natively. So before Kotlin Multiplatform, we had a very complex diagram. And this is sort of illustrating how if you are if your company says, okay, we're going to develop an app for Android, iOS, and desktop, and it's sort of going to have the same functionality, it's just going to be on different platforms, you would have to create the different sort of layers of application for each one of them. There was nothing shared. So each application would have a data and core layer, sort of going from the bottom, a business and domain layer, a presentation layer, and a UI layer. That's kind of the standard stack for applications. So, and you would have duplication between Android, iOS, and desktop. But with Kotlin Multiplatform, you can start sharing the business logic. So here we are sharing the data and core layer and the business and domain layer and writing it as Kotlin Multiplatform in a shared module. And the things, you can see those blocks at the top are what we're actually writing natively. We're writing desktop, Android, and iOS, the presentation and the UI layers natively. So you can take it one step further and also share your presentation layer of presenters, view models, and controllers. but you can, and then you write your UI layers natively, so your views natively, so it will have that native look and feel depending on what platform you are on. But again, the choice is yours, what you share and what you don't share. You can also, with Compose Multiplatform, take it even further and share your UI layers as well. And the only code that's really sort of left for and that can't be shared is your platform specific code. Next is also that you can start sharing your UI code, and I alluded to this a little bit before. So before Compose Multiplatform, we had Jetpack Compose, which is sort of a toolkit for building in a very declarative style based on the Kotlin compiler. Start writing beautiful declarative style UIs for Android. But JetBrains took it one step further and created Compose Multiplatform, where you can write UIs for Android, iOS, desktop, and web. And so this is the current state of the platforms. For Android, it's stable. For iOS, it's in alpha. For desktop, it's in stable. And for WASM, it's still experimental. We are looking to take iOS into beta next year and WASM into alpha as well next year. And this is to give you an idea of what how beautiful the apps that you can create with Compose Multiplatform can be. So this is an image viewer app which runs on Android, iOS, and web, and it even has integration with native components like the map and the camera. This is another community sample, the New York Times clone app, and it even runs on Wear OS for watches, so Google's Wear OS. And something actually quite big that we don't always realize is that desktop development has really been very much neglected for the last forever. And desktop development has been, in the sort of 2000s, 1990s, it was very much either Qt or Swing or Java Swing and so on. And then later on it became Electron and other frameworks like that. But for the JVM, now we have a modern development framework that is Compose Multiplatform. My next last reason is that it's comparable, the performance is comparable to native. So in terms of dependencies, there is support for Apple APIs like Foundation and Metal out of the box. There are Kotlin bindings that just basically are there and that they just work. You don't have to do any extra steps to access them from Kotlin. If there is dependencies published as CocoaPods, there is just a little bit of configuration that you need to do in order to use CocoaPod dependencies. And then if something is not managed by a dependency manager, like a file on the disk, then it is still possible to use that dependency. It just takes a little bit more configuration. And it makes the common easy and the less common possible. In terms of performance, there are no reasonable use cases known to be significantly less performant than other native and other cross-platform technologies. So this is very specific. I want to be very specific here. This is for Kotlin Multiplatform, not Compose Multiplatform. And this is also measuring for use cases related to user experience. So very much to do with if it is something that would affect user experience rather than something that is like a benchmark. If there is a use case that we see that there is performance issues, then it's definitely something that we're open to getting feedback and fixing. And we'll definitely try our best to handle it and not leave that query unanswered. My last point is that Kotlin is a loved and trusted language for everyone. So what do people say when they talk about Kotlin? Firstly, they say that it's concise. You can write really short programs use it to write really short programs. It's expressive. You can solve a whole bunch of problems. It's original. It has some unique features, and it is sound. You can sort of prove that your programs are mathematically prove that they are correct. But Kotlin actually doesn't aim to be these things. It actually aims to be a lot more pragmatic, a lot more practical. So it favors readability over concision. Just because a program is short doesn't mean that it's a really good one. It's better to have eliminate your boilerplate and not to focus on concision for its own sake. Reuse over expressiveness. So just because you can solve a whole bunch of problems and do so many things doesn't make it like a superior kind of programming language. If you can even go further and take those problems that you've solved and extract them into libraries, that makes it even better. And the interoperability over originality. So this has to do with, standing on the shoulders of giants, like, for example, that Kotlin did with many languages, but also Java. And the nice thing about this was because Kotlin was interoperable with Java, we could sort of use all those existing, that ecosystem that already existed, and safety and tooling over soundness. So the compiler will catch your bugs and the type system will enable your tooling to make you more productive. So Kotlin is designed to make developers happier. And you can see, according to a survey that we recently did, is that 86.1% of Kotlin developers are actually very satisfied with Kotlin. Kotlin also makes developers more productive. 70% of developers that are using Kotlin as their main language says that Kotlin makes them more productive. And let's look at a feature where we can see this in action. So that is data classes. Say that I have a data class person with a first name, second name, and surname. And you'll notice there's a little question mark at the end of second name because not everybody has a second name. So what is kind of implicit in data classes is your getters and setters for each property, your equals method, your hash code method, your toString methods, copy methods, and your component in, which is for your destructuring declarations. There's also fewer crashes with Kotlin. When of the top 1,000 apps on Google Play, those apps that are created with Kotlin have 20% less likely to crash. For example, an app called Swiggy lowered their crash rate by 50%, and they're about 74% Kotlin. So let's have a look at how a feature that makes Kotlin a little bit more safe. So the way that it handles null is a definite big feature of Kotlin. So say that we've looked at this data structure, this data class before of a name, and say that we want to print the name in a very naive fashion. We want to print the first name, second name, and surname, and then we have two sets of test data. We have Adele Blue Atkins and then Taylor Swift. Now say that Taylor Swift doesn't have the second name. When we print this out, it will say Taylor Null Swift instead of Taylor Swift. Our next example is to sort of push the boundary a little bit more. And we want to print the second name in uppercase. So what we have to do is we will have to use a little null operator, a null safety operator just before the uppercase to say, if this second name is null, just return null. Otherwise, make the second name uppercase. So then we would get for Adele, with uppercase blue and then Atkins. But for Taylor Swift, we will still go ahead and get Taylor Null Swift. So we won't get a crash here. And our third task, or if you count like a programmer, our second task, our task number 2, is to print the second name in uppercase if it is available. So there we use an Elvis operator to just make it an empty string if the second name is null. So here you get Adele with uppercase Blue Atkins and Taylor Swift just as it is. There's no null printed out. Kotlin also improves your safety and correctness. So the number one cause of crashes on Google Play is the dreaded null pointer exception. And so when Google Home started incorporating Kotlin, they saw a 33% reduction in null pointer exceptions over the year that they started writing new features in Kotlin. That also, the way that the type system also works also helps you avoid making mistakes at compile time rather than in production. So a good example is the way that it handles equality. And here we can see that in Java, if we want value or structural equality, so all the data inside of it is the same, we would have to use dot equals. But for referential equality, the object reference is the same. We would use double equals. But in Kotlin, we actually say, people are in general going to think more in the double equals way. It's more mathematically correct to use that for structural equality, and use for referential equality, which is a lot less useful and a lot less common. We would use the triple equals operator. So I always used to joke when I was doing Java, to equal or not to equal, that is the question. So you were always wondering whether you should use an equal operator or a dot equals operator, and that is it was my little Java Hamlet joke. So where is Kotlin actually used? So Kotlin is used on Android. About 66% of those surveyed were using Kotlin for Android, but 20% is using it or 20% of the people that were surveyed were using it for server-side, and 14% were using it for other. I don't know what other could be. So 95% of the top 1,000 apps on Google Play use Kotlin, and of those, 23% of them use Jetpack Compose. But you can also use Kotlin on the server side, and these are some examples of Kotlin web frameworks like Spring, Ktor, Micronaut, Quarkus, and so on, with many other frameworks that are quite popular. So perhaps I've convinced you to try Kotlin multi-platform. So what is next? So first, you should start super, super small with just using constants, a small shared irritation, maybe something that you find difficult to keep consistent, and some shared common utilities that you can do. Then you should work out the experiment plan. You should think of what is the hypothesis? What do you think should happen? Then the method, how will we go about our experiment? And then how will we analyze the result or conclusion? So first we need to think about a whole bunch of things in our experiment plan, like who will be contributing to this shared code? What will the team be? What is your workflow going to be like? How are you going to make and distribute changes? And coding standards, how do you write nice looking APIs for your Swift developers to consume? CI/CD, how do you test and roll out your changes? And how do you monitor production? And how do you make sure that nothing breaks because of the new technology that you've adopted? You then should, once you've started gaining trust, you should expand the scope. And then you should really think about, did this really work for us with a retrospective? And then if yes, do we want to expand the scope of this technology, using this technology, or no? Why? And sometimes, there's a paradigm that says you should think about people, technology, tools, and processes. What contributed to this not working for us? Was it something external, internal? Was it something that could be prevented, or was this technology just not the great fit for us? So in summary, Kotlin multi-platform is a great choice for using in your projects because it's already being used by big companies. There's an extensive list of supported platforms, a supportive community like Google, TouchLab, and a whole bunch of other individuals. We avoid duplication, and we also make sure that we're nice and consistent amongst our platforms. We can use it in new or existing projects, so you don't have to start from scratch. You can start sharing gradually, and you can choose what to share and what to write natively. You can share UI code now with Compose Multiplatform, and the performance and the dependencies are comparable to native, and because of Kotlin. Kotlin is a loved and trusted language for everyone. In terms of my call to action, start small, work out the experiment plan, and gain trust, and then expand the scope. So I'll remind you of my Slido again. So if you if you want to ask a question, depending on whether this is going to be just broadcast, and I answer the questions on Twitter, I'll answer them at a later stage. But if this is going to have a live Q&A, then please go ahead and answer your questions, or ask your questions, and I'll answer them for you. And with that, thank you, and have a great DroidCon Uganda. I'm going to slip back to the Slidos link so that you can go and have a look there. Okay, thanks.